lecture on heat transfer. Myself Khushbu Shah, Assistant Professor in Chemical Engineering Department of LJIET Institute of Engineering and Technology. In our previous session, we have started a new chapter number 5, which is boiling and condensation. In that session, we have covered one important topic, which is the pool boiling of saturated liquid. Now in today's session, we will start with a new topic, which is heat transfer in condensation of vapors. We know that the change from liquid to vapor is known as vaporization, and opposite to that, from vapor to liquid is known as condensation. In either case, latent heats are involved and it is identical, right? Because we know that when there is a phase change, the latent heat is very important and that we have to consider, right? So in condensation also, the latent heat involved are identical. In condensation of pure vapor, it is necessary to remove latent heat of vaporization to convert it from vapor to liquid, right? In any condensation process of pure vapor, it is very important to remove latent heat of vaporization. Condensation occurs by two different mechanisms and at very different rate of heat transfer. Let's see what are that two mechanisms of condensation. First is film-wise condensation and second is drop-wise condensation. These are the two different types or two different mechanisms by which condensation occurs. In both the cases, rate of heat transfer is very different. Let's see both the types of condensation in detail. Let's start first with film-wise condensation. When a saturated vapor comes in contact with the cold surface, it condenses, and if condensate wet the surface. This is very important. This word is very important. Whenever a saturated liquid comes in contact with the cold surface, it condenses. And if that condensate wet the surface, it forms a continuous film of condensate through which heat must be transferred. Again I am repeating. When the condensation occurs, the condensate wets the surface and it forms a continuous film of condensate through which heat must be transferred. And the condensate ultimately falls down the surface under the influence of gravity. This type of mechanism is known as film-wise condensation. Why we call it as film-wise? Because in this type of condensation, the condensate which forms on the surface forms film on the surface. It forms as a liquid film, condensate film, and that's why we call it as film-wise condensation, right? In general, this film-wise condensation occurs on smooth and clean surfaces. Remember these things. Film-wise condensation occurs on smooth and clean surfaces. And film-wise condensation is very common and reliable, and therefore design engineers assume film-wise condensation in most of the process equipments. As the film-wise condensation is common and reliable and it is very stable, because it forms the film on the heat transfer surface. That's why in designing purpose, majority time we assume the film-wise condensation in any heat transfer equipment. In case of film-wise condensation, methods for predicting film coefficient are available. As heat transfer is occurring, we have to calculate heat transfer coefficient or film coefficient. So in film-wise condensation, we have the equation to calculate the film coefficient or heat transfer coefficient. Let's see what are that equation. For film-wise condensation on vertical surface, the mean heat transfer coefficient is given by this equation. See, Hm is equal to 0.943 rho square G lambda K cube divided by mu L delta Tf whole raised to 1 by 4. This is an empirical equation. You have to remember this equation. This is the equation to calculate heat transfer coefficient in film-wise condensation on vertical surface. When it is asked to calculate the heat transfer coefficient for film-wise condensation on vertical surface, then we have to go for this equation. In this equation, Hm is the mean heat transfer coefficient, L is the tube length, G is the acceleration due to gravity, mu is the fluid viscosity, lambda is the latent heat of vaporization, K is the thermal conductivity of liquid, and delta Tf is the temperature difference between vapor and metal. Right? So, this is the equation to calculate heat transfer coefficient in film-wise condensation on vertical surface. But what if there is a film-wise condensation on horizontal surface? At that time, for film-wise condensation on horizontal tube of outside diameter dO, the mean heat transfer coefficient is given by this equation. Hm is equal to 0.725 rho square G lambda K cube upon mu dO delta Tf whole raised to 1 by 4. So, these are the equations to calculate the heat transfer coefficient for film-wise condensation on vertical tube and on horizontal tube. So, in film-wise condensation, we have this expression or we have the formula to calculate heat transfer coefficient. Let us see some parameter of the drop-wise condensation. What is drop-wise condensation? When a saturated vapor comes in contact with the cold surface, it condenses, and if condensate does not wet the surface. In film-wise condensation, condensate wets the surface, while in drop-wise condensation, condensate does not wet the surface. And it forms droplets on the surface. And that's why we call it as drop-wise condensation, as the name suggests. In film-wise condensation, condensate forms the film on the surface. While in drop-wise condensation, condensate forms as a droplets on the heating surface. And that's why we call it as drop-wise condensation. The drops which forms grows and ultimately falls from the surface under the influence of gravity and leaving the bare metal surface for further condensation. Right? As the heating goes on, the droplets grow and ultimately falls due to the gravity effect and leaving the bare metal surface for further condensation to occur on that surface. And this type of mechanism is known as the drop-wise condensation. In drop-wise condensation, it is generally occurs on oily and greasy surfaces, and film-wise condensation occurs on smooth surfaces, while drop-wise condensation occurs on oily and greasy surfaces. Also, drop-wise condensation is unstable and difficult to maintain. Drop-wise condensation is unstable and difficult to maintain, as well as the design methods to calculate film coefficient in case of drop-wise condensation is not available, and that's why this type of condensation is not common in industrial application. Right? Because drop-wise condensation is unstable and difficult to maintain. As well as to predict the heat transfer coefficient, we do not have any equation for drop-wise condensation. So, in industrial application, this is not preferable type of condensation. Right? So, this is about drop-wise condensation. So, from this, you can differentiate easily between the film-wise condensation and drop-wise condensation. Right? So, I am completing this session here. In today's session, we have covered what is the difference between two types of condensation? And this is very important question. In exam, it is repeatedly asked, differentiate between film-wise condensation and drop-wise condensation. You have to just remember the points. Which are the points? Film-wise condensation wets the surface. Drop-wise condensation does not wet the surface. Film-wise condensation occurs on smooth and clean surface. Drop-wise condensation occurs on oily and greasy surface. Film-wise condensation is easy to achieve and stable and reliable, and that's why it is industrially applicable. While in drop-wise condensation it is unstable and difficult to maintain, and that's why the drop-wise condensation application is not more. And the last point of difference is what? Film-wise condensation. In film-wise condensation, we have the equation to calculate heat transfer coefficient. While in drop-wise condensation, there is no such equation available to calculate the heat transfer coefficient. Right? So that's all about today's session. I hope the session is clear to all. Thank you.